So we're going to move on to the non-hydrolyzable lipids now. So the first one of these is to look at cholesterol. So cholesterol is a steroid, and what I want you guys to learn or be able to recognize is this structure right here, which is a steroid skeleton. So basically, any molecule you look at that kind of looks like it has this as part of it, you can consider a steroid. So basically, it's a six-membered ring, fused to a six-membered ring, fused to a six-membered ring, fused to a five-membered ring. So if you see that kind of general structure, you should say, oh, that's going to be a steroid. Cholesterol has that part to it. So right here is that steroid skeleton we just talked about. Cholesterol also does have this double bond right there. And again, you don't need to know the details of this, but I want you to recognize cholesterol as a steroid. And the reason that we also consider cholesterol is a lipid is, let me erase all the pen markings and then come into and draw it again. If we look at all of this part here, notice it's all a skeletal structure. Means there's only carbons and hydrogens. So all of this part here is going to be nonpolar. And we identified lipids earlier as molecules that have a mixture of a polar and a nonpolar part. The polar part is that little OH there. So that's the one little polar part to cholesterol. So cholesterol is still considered a lipid because it has both the nonpolar and the polar moieties to it. So cholesterol can be obtained in our diet through meat, cheese, butter, eggs, and many other sources. And it's also synthesized in our liver. So again, we get cholesterol made endogenously by our body, and we also get it in our diet. If you get too much cholesterol, that can lead to coronary artery disease, so it can lead to congestive heart failure, heart attack, stroke, and things like that. And the reason for that is because cholesterol is insoluble in the aqueous blood. So again, we identify lipids as molecules that are soluble in organic solvents and insoluble in water. Well, the blood is in aqueous solutions. Remember, aqueous means in water. So cholesterol is going to be insoluble in water or insoluble in the blood. So that means it's going to form plaques. It's going to form these deposits in our arteries if it's left there. But cholesterol is still required. If you remember looking at our cell membranes, there were pictures of a cell membrane. We showed cholesterol is kind of embedded in the cell membrane. So in order for cholesterol to be moved through the body and to traffic to different areas where it needs to be, it actually is transported through proteins that are called lipoproteins. So lipoproteins are going to be aggregates or combinations of phospholipid and proteins. And there's two main classes of these lipoproteins. There's low density lipoproteins and high density lipoproteins, or they're abbreviated LDLs and HDLs. So if you go get blood work done, they'll run your cholesterol levels, and what they actually measure are your levels of HDLs and LDLs. So HDLs are considered your good cholesterol, and LDLs are considered your bad cholesterol. And again, keep in mind that these HDLs and LDLs are actually proteins, but they're aggregates of proteins with the phospholipids. So they kind of go together in one structure. So here's kind of what that structure looks like. You have a protein core to it, which you can see here. And then attached to that protein core, you have a whole bunch of phospholipids. And these are the green dots that you see in this structure. And then you also see cholesterol in yellow. So these are going to be large structures that are basically embed cholesterol within it. And these lipoproteins are soluble in the blood. So they're able to form these small little soluble particles that can go through the blood, reach its destination, they kind of dock with their destination, kind of give them almost an injection of cholesterol whenever it gets there. So this is how we actually move cholesterol through the body, is through these lipoproteins. So again, this is a picture of kind of what your HDL or LDL would look like. So what's the difference between HDL and LDL? So LDL, which is the bad cholesterol, they deposit cholesterol on your walls of your arteries, whenever there's more of them than needed. So basically, LDLs carry cholesterol from the liver where it's synthesized to other tissues. So think of these as one directional transporters. So LDLs take your cholesterol and they transport them to other tissues. So LDL's carrying it, it's going to another tissue. It gets to the other tissue, and that tissue says, oh, I'm full. I already have enough cholesterol. Well, then the LDL is like, well, now I don't know what to do, and it just deposits that cholesterol in the artery wherever it is, and it sits there. And if it keeps doing that, and the LDL keeps depositing cholesterol somewhere in an artery, that's what leads to this plaque formation. And that's what restricts your blood flow, and that's what leads to high blood pressure and heart attacks and stroke and all that thing. Okay, so LDL is going to be our bad cholesterol because of that. HDLs are the quote-unquote good cholesterol because HDLs pick up cholesterol from the arteries and bring them back to the liver. So HDLs can actually remove this plaque formation by picking up the excess cholesterol and taking it back to the liver. And this is why, like years and years ago, you would go to the doctor and they would just measure your total cholesterol levels. And nowadays, what they do is they measure your ratio of HDL to LDL, and you're really looking for that ratio. You can have higher levels of total cholesterol as long as you have an excess of the HDL.